asked to isolate x in this matrix equation, we can assume that A, B, and C are n by n invertible matrices. So each of these have dimensions n by n. So there won't be issues with being able to multiply because of the dimensions. Since they're all n by n, then the dimensions will match whenever we want to multiply. And we can assume that each matrix here has an inverse. Okay, so the goal here is to isolate x. So one thing we could do, let's say we want to get rid of this c in the front. We could multiply on the left by c inverse on both sides. So if I multiply by c inverse on the left side of this equation, multiply by c inverse on the left side of this expression, I should say, then switch to black here. So the c inverse times c now gives me the n by n identity matrix times, okay, well, b plus x times a inverse. And then over here, so any n by n matrix times the n by n identity matrix will just give me back that same matrix. So now I just have c inverse on the right side of that equation. And then same deal here. So multiplying by the n by n identity matrix times all of this is just going to give us back that same matrix, whatever this is. Okay, so I have this equation now. I'd now like to get rid of this A inverse matrix on the right. Sorry, I'm a little slow this morning. Because, remember, the overall goal here is to isolate x. So I'm going to multiply on the right side, on each side of this equation, by A. Multiply by A here. So now this A inverse times A will give me the n by n identity matrix. That's just what invertible matrix, the inverse of a matrix does, is when you multiply a matrix by its inverse, it gives you the identity matrix. And so I still have the b plus x here, and so now it equals c inverse times a, and then multiplying any matrix times the identity matrix is just going to give me back that same matrix. So b plus x here equals c inverse a. Okay, so now I would like to, still the goal is to isolate x, so we need to do something about the b in the front here. So the last thing we need to do is subtract the matrix b from both sides, because if you have a matrix b minus itself, then you're going to have these n by n matrices where all of the elements of the matrix match. So when you subtract, you're going to have 0 in every position. And so that'll zero out the b part of that sum on the left side. So if I subtract b from both sides, sorry, I'm going to write this out. So b plus x, and then we're going to subtract b here, and the b minus b, this gives us the 0 matrix plus x. So just a matrix with all zeros plus any matrix, that's just going to give you back the same matrix, as long as they have the same dimensions, which they do. They're all n by n. But we do have that requirement. Okay, but if I subtract b on the left side of this equation, then I need to also subtract b on the right side. I'm trying to have all my colors match up here. Okay, so x is equal to c inverse a minus b.